Okay, so hi guys, thank you for joining this session. So my name is Nikolay. I'm a developer for a long time, more than 15 years. Started with C, C++, going through .NET, even Perl and PHP, and currently I'm coding in Java.
Hi, I'm Atanas, and I've worked in the breadth and depth of the industry. I've worked from embedded image capturing solutions to Forex trading, VoIP, software with user-facing interface and whatnot. And what I'm here to tell you that it doesn't matter what you do because you're always solving a problem. And my motto is, I do what I like and I like what I do. And now we are going to explore a custom problem that a lot of us are going to face or are facing right now. Whatever you do, you end up joining a new team. It's either your first job or you make a transition. And how many here have the luxury of working on a brand new piece of software from scratch? Wow, look at the lucky guys. As I recently read on the internet, code lives forever. Developers change. And chances are, one way or another, you'll end up in a company which already has a working solution, which is making money, and people are happy with it and want to sustain it. And you join a new team, and you're very excited because you're always looking for a better opportunity, a new opportunity, a better team. And right there, this is you in the middle, happy with your new colleagues. Everybody's around you, trying to accommodate you, make you feel better. The induction period goes well. You're optimistic. Suddenly, a month passes by, and you have to do your first user story. And you don't want to disappoint your colleagues. You want to look smart, because you are smart. You want to impress your product owner. And you're sifting through the code, looking for the perfect place to put your small line of code so that you prove yourself. And suddenly, you're in trouble. Because the code is a mess. The business logic is not easily correlated with the software you're seeing. And if you attended the keynote this morning, it was very descriptive, because you always have to have design which corresponds to the domain, the problem you're solving it. And what can happen is that you can panic in this moment, because in moments of panic, like you're facing in your imaginary situation, people usually choose the bad approach, the shortcut approach to software development. And this makes the life for people coming after them very hard. Because when you're faced with a problem, you know the current situation and you start to work around it. And it's even scarier if you're one of the cowboy coders, which is the attitude of, I'm going to fix this and I'm going to show you how to fix this and nobody else matters. There's a cool Wikipedia page on this article which you can check. And what my colleague and I are going to try to convince you with presentation is to have a shift of your focus on how you approach the work that you do and how to leave a project you're working on in such a state that people that come after you do not hate you.
Okay, so let's start with another quiz. I'll ask you two questions. First of questions, how many of you have been in this situation so far? Quite, great. And how many of you participated in solving this situation, updating the processes in order to have a better place to work and enjoy? Great. So what I hope that you'll get after this session is that you're gonna compare your actions that you take in your processes with the things that we will show you and will present you. So I hope that everyone read this sense. And actually, I was in boots and on shoes in this violent psychopath that wanted to know where the previous coder lives. So for the rest of the presentation, we'll try to show you best practices and good approaches that we think will solve this issue that Nasko just explained and make your life easier and happier. So Nasko finished with bad attitude. let's go to the good attitude. So first thing that we think that you should do, not only you, but the whole team that you're working on, is to maintain clear code and proper documentation. Clear code and also proper documentation are vital for your project, for your daily work, and not only for your daily work, but for the daily work that your colleagues and the ones that are going after you, not after you, but after your code, because clear code will lead to the smaller time for implementation, more easy understand of the problems that this code is solving, and more easier to you to plug in your next code and your new code. And the proper documentation, I'm not sure if I have to elaborate more on this, but proper documentation is vital not only from a business perspective, but also from a technical perspective, in order to show how the business rules are implemented and what kind of approach is used in order to these rules to be implemented. Next one is something that I hope that all of us are doing, but adding meaningful comments is also vital, and also they should be added where they're needed and where is suitable. Adding comments, something like if this variable is equal to 0, and the same, the next line is actual if is not a meaningful comment. And also, for me, meaningful comments should be something in the beginning of the class, explaining the business logic and all the problems that this class should solve, and also in the beginning, at least in the beginning of the method, where you can explain the actual rule or actual business needs that are solved there. Also, it's normal to put some additional comments inside the method in order to explain some, let's say, heavy logic or really tough logic, why this is done, and etc. Next thing about the good attitudes, it is all of us, we use some processes in our daily work, in all of our projects. And mostly these processes, they've been creating in the beginning of project, and throughout the whole software delivery life cycle, the needs for the process may change. So the next thing about the good attitude that you can use is to assess these processes on a regular basis, 3-6 months, depending on the project. And if this process needs to be updated in order to make your life easier and to do your job better. So I just take some comments from internet. I'm sure that maybe most of you saw this. Actually, the most, let's say, good for me, it's a C++ column. It's define true equals false, and the next comment is happy debugging suckers, which is a really good comment. So, what I'm going to talk over is the best practices that we think should be implemented and widely used. So the first thing is, this is actually my favorite, is that any code written half or maybe 3 months before current date, it's kind of legacy. And if the code has proper unit testing, integration testing, etc., then this period can expand, but not more than half year. So my vision that it's each 6 months you have to review your code, check if it's okay. Even if you don't introduce new features or new logic, just go check your code, examine it, and if needed, change it in order to apply better code, new good practices, in order to be more readable for the others as well. Next thing is you have to use and apply coding standards. Each program language that is used lately and not lately, it has a common and standard coding standards that you can use. You can apply this coding standard, also updating and customizing it in order to suit your department or your project and your team. And obey these coding standards and ask all of the team and also the newcomers to apply and comply with these coding standards. And I think the first thing that the newcomer should do is to read and understand the coding standards, so this new person can follow them and write the proper code. And the next thing is related to the previous one, the coding standard. You can use, there are plenty of good code quality tools. Use these code quality tools in order to be sure that these coding standards are okay and all of the team members complies with it. And also all code quality tools, they have some feature that they can pinpoint or check for some vulnerabilities, well-known vulnerabilities. So it also, they can give you some information if something has to be changed in order some specific vulnerability to be avoided.
So what Nikki already described is very important for you to do your job better, but it's also very important because all of this actually tells a story. The story of how a business problem was solved, how your product is being built, how your product is being integrated, and how your product is being deployed. And if this is not passed from mouth-to-mouth knowledge from your senior integration guy to your senior QA guy, but it's rather simply laid out in an automated process, whenever a new person comes, he can actually use this story to understand what the product is doing and how it's supposed to be doing it. And whenever a new person comes, it's especially valid for fresh out of university people because they're the most hungry guys to prove themselves and to make their stamps. And they tend to not ask questions and just try to solve it. But also when seasoned developers join a team, they usually have this air of hubris around them and this know-it-all attitude. And they also tend to dig in the code. And sometimes they can spend enormous amount of time trying to understand everything in a piece of code which actually is irrelevant to the overarching problem and what they are about to do. So going back to your imaginary situation where you just join your new dream team and you're feeling lost, because chances are this new dream team was pressured by aggressive deadlines, it was pressured by the customers changing their requirements. They didn't have the time to follow the practices. They didn't have the time to automate their process. They don't have a readily laid out story to tell you how their product came to be. They're busy developing new stuff. It's important to keep calm because everybody has been in this situation one way or another. The next step is you need to identify the people who can help you. The problem domain experts, not just in the code, but rather what this software is trying to do. Because if you can map out the business logic to the code, you are more than halfway there. Because whenever you have to do something, you'll be able to navigate where to actually go instead of trying to read, let's say, 100,000 lines of code which has existed for decades. And it's hard to maintain and understand all of this. So you have to identify the domain knowledge experts. You have to be able to communicate with them so that they can tell you the story of the product, so that you can actually understand where and what's happening. You have to be on a friendly basis with them, of course, in professional terms, so that whenever you're in need of help, they can be there for you. And it's important to always ask questions rather than staying lost, because you're hurting your team and you're hurting yourself, because it's really depressing to be sitting there not being able to do anything. Of course, as I mentioned, I believe that any software, no matter what the software is, it's virtually doing one thing. And software on its own has no value. Maybe the only software with any value is artificial intelligence, but that's debatable. So whenever you are working on a project, you always have to shift your focus, not how something is done, but why this is done. And I think that this is very hard because engineers have this intrinsic need to understand all the code. And it's very important to step back and to know that you don't have to understand all the code. It is very much possible that a piece of code has not changed for a lot of time. And maybe the problem domain that it's actually servicing in such fashion that it will not change for the next 10 years. And you will not probably gain anything for spending 2 months understanding this software, nor will the project and your team have any benefit of this. So it's very important to compartmentalize the software, be able to focus on the important things, and only dive in on a need-to-know basis. It's very important to also know the so-called historians of the product, people that can tell you why some things happened. Because something that to you looks like very unprofessional and very badly written can be the product of specific circumstances. And for example, if you take a HTTP server written in C 20 years ago, yes, it will probably look messy. It will probably be very hard to maintain. But this is the reality that this software happened, and you have to accept it. You have to know the business problem that is being solved. And maybe the most important shift is actually the people who said that they are working on inherited product. How many of you like the code base you're working with? Wow, 2 guys.
3.
3 guys. Now this attitude has to change. You don't have to like the code. You don't have to view it as good code or bad code. This is code which it has already solved a business problem. It's probably making money, and that's why you joined this company. And it's just code, it's just there. You don't have to feel sorry that it's hard to maintain. Rather, you have to focus on how to make this code maintainable, how to build your safety net around it so that you can go in and start making changes to this piece of code with confidence, knowing that you're not breaking everything and the CEO coming after you. And it's very important that at this stage you actually focus on automation, on telling the story which has not been told, and you have to own the code because this is your code now. And whatever you do, it's your responsibility. And you have to leave any project you work on, you have to leave it in such a state that you can actually grow from this position, because you need new people, junior people coming in, easily taking the ownership of this piece of code so that you can move to your new challenges and actually solve your new problems. So unfortunately, it's not always possible to have people to rely on. Myself right now, I'm at such a situation where I've worked on a project for a couple of years, and now I'm starting work on a brand new project. But I had the luck to have one of the main developers there sit with me for a week and tell me the story of the project, which was great. But it is often the case that you may end up alone. And then it's very important to always keep to the problem domain. First, you need to understand what the problem this software is solving. Because when you know the problem, you can look for specific things and patterns, and in 90% of the time, any software is just moving data about. An image capturing software, Forex trading platform, or whatever else you can think of, maybe only software which is supporting other software, all it's doing, it's taking some data, which is business critical, applying any modifications to it, committing it to storage, presenting it to the user. And you have to know what this data is so that you can follow the data through the code. And your most important focus should be to identify the main logical pieces in the software which are actually manipulating this data, so that you can track the changes in the data and infer the logic from what's happening to the data. Because software on its own has no value except from what it's actually doing to the data, because this is what the problem is usually about.
So, last comment about automation processes. Currently, continuous integration and continuous deployment or delivery is something that is widely used and implemented. So I'll try to somehow generalize this in the next few slides in order to finish all of our presentation and to give you some thoughts about how automated processes can improve the situation that we started in, and how also can improve your daily jobs. So continuous integration mostly start with code quality task. So code quality is a vital part of automation process, and code quality is used to check the code before the actual build in order to prove that the code is checked in using agreed coding standard, and also that is free for some vulnerabilities. Next thing about the automated process is the actual build process. So actual build process is doing process like code checkout, compiling if needed, because the compiling may not be part of the build process depending on the language that you're using, and also packaging and any additional process that related to the project. Like, for example, adding some reports somewhere, creating reports from the code quality tools, and also for the build tools. Next thing about the automated process is automation testing. Automation testing is another, I think, really vital part of the automated process. And in order to be sure that all of the changes that are checked in and are going to be used for the next build are okay and production ready, you have to have a proper testing automation tools and prepared tests. So these tests should confirm that your code is regression tested well, integration tested well, and also any additional tests that are needed, again, depending on the project specifics. And once the tests are proved that your code is okay to go to production, then the last process is deploying the continuous deployment. Continuous deployment is whenever the previous parts are okay and acceptable, then the deployment should happen. The deployment can happen on different ways. It can be started automatically after the test is finished with predefined configuration, or you can do it manually depending on the type of deployment that is to be done. It can be deployed, fully deployment of the system to a production or whatever servers you are going to deploy, or the deployment can be custom depending on the changes that needs. You can do some partial deployment depending on the fixes or change requests that were implemented with the latest change.
So the key takeaway that we'd like you to have from this presentation is that currently most of the people, either developers or QAs, have this very technical focus, and especially developers that tend to be very defensive about their choices, about what language they're working with, what's the best methodology, and whatnot. And actually, this should not be your focus, because you're not a coder. You're actually architecting solutions to problems. You're slicing them up in bite-sized chunks, which are easy enough so that a glorified calculator can execute them. What you have to do is to solve the problem, outline the problem in a simple manner, so that even when all the code is being written by machine learning processes, let's say, you're still going to be the most valuable asset of a company, because you're actually making solutions and not doing the code itself. And now is the time for QA. And because the presentation is very all-encompassing and vague, I'm guessing nobody has questions. In any way, if you want to reach us, you can use these contacts.
We come to experience tent.
Yeah, also. Thank you very much for
Thank
your
you, guys.
time.